Hi, in the previous video, we talking about temperature specific volume diagram, and we illustrate at a constant pressure line, and as you continue add heat to it, this is going to be the constant pressure line. And how about today we're going to be looking at the PV diagram. So instead of temperature, we have pressure versus specific volume. It also starts with a dome shape. I have the same thing, 1, 2, 3 region, and being 1 being compressed liquid, and 2 is going to be the saturated liquid vapor mix, and also number 3 will be superheated vapor. So will everything be the same thing then? Will the trend gonna be going like this or not? If we do this, if we're going to change that to constant temperature, let's see what happens. If this constant temperature, okay, now when we are going to go up this way, what happened? The pressure go up, right? Because pressure does go up. Think about when pressure go up, you basically increase the pressure onto the substance. What does normally happen? What happened to the volume when you increase? When you press something really hard, the volume compress, right? So volume should go down. However, what happened to here? The volume, you notice, go up. So that just tells us this is not right. It doesn't work like this. So I'm going to say this is not right. So what would be the correct way when you draw a PV diagram then? You have the same dome, you have the same region. However, it should follow this way, the other way around. That's going to be our constant temperature line. Why? Now let's think about it. If you go this way, so that'd be this direction when the pressure go up. When the pressure go up, what happened to the specific volume? It decreases. And that's what we want. Okay? Now if we were trying to draw another temperature, if we would draw a temperature like that, that's T2, and this is constant temperature T1 and T2. So the same thing. Remember, when pressure goes up, the temperature, boiling temperature, should go up, the saturated temperature. Whereas in this situation, if this temperature, we're going to call this point corresponding here, for example, that's going to be our, at that temperature, our saturated pressure. Okay, that's going to be Psat at T2. And here, it's corresponding to that temperature. That's going to be Psat at T1. Let's make it more relatable. For example, if, let's use the number we know. If this temperature is 100 degrees Celsius, okay? If this constant temperature is 100 degrees Celsius, what do you think this Psat is going to be? Psat means at this 100 degree, this water is gonna boil, okay? And what's the pressure then? It's gonna be 1 atmosphere pressure, right? So in that situation, if your T1, if your Psat1 is greater than Psat2, which is at this y-axis, so we can know T1 is gonna be T2, greater than T2 from this chart here. Okay, so that is still the proportional. Okay, so that's our PV diagram. How is that different from our TV diagram we had before? So you realize the trend is just taking the complete opposite direction. Okay, that's all for PV diagram. See you next time. Bye.